Chapter 1. Integers. Introduction. We have learnt about whole numbers and integers in the previous class. Positive numbers 1, 2, 3, 4, etc. are called natural numbers. When we add number 0 to the set of natural numbers, we get the set of whole numbers. When we add negative numbers, -1, -2, -3, -4, -5, etc. to the whole numbers, we get the set of integers. So, -3, -2, -1, 0, 1, 2, 3 are integers. In this chapter, we will study more about integers, their properties and operations. Recall. We know how to represent integers on a number line. We know that on a number line, there are positive numbers 1, 2, 3, 4, etc. are on the right side of 0, and negative numbers -1, -2, -3, etc. are on the left side of 0. Some integers are marked on the number line as shown here. Can you write these marked integers in ascending order? The ascending order of these numbers is -5, -1, 3. Here, -5 is the smallest number and 3 is the greatest number. Because -5 is on the left side among all marked numbers and 3 is on the right side among all marked numbers. Some points are marked with integers on the following number line. Write these integers in a descending order. The descending order of these marked integers is 14, 8, -4, -9, -16. Here, -16 is the smallest number and 14 is the greatest number. Now, because -16 is on the left side among all the marked numbers and 14 is on the right side among all the marked numbers. For example, a number line representing integers is given below. -3 and -2 are marked by E and F respectively. Which integers are marked by B, D, H, J, M, and O? Solution. Here, the integers -6, -4, 0, 2, 5, and 7 are marked by B, D, H, J, M, and O respectively. We have done the addition and subtraction of integers in our previous class. Read the following statements. On a number line, when we 1. Add a positive integer, we move to the right. For example, 3 plus 5 is equal to 8. 7 plus 4 is equal to 11. 5 plus 5 is equal to 10. Add a negative integer, we move to the left. For example, 3 plus negative 2 is equal to 3 minus 2, which is equal to 1. Negative 4 plus negative 3 is equal to negative 4 minus 3, which is equal to negative 7. Minus 7 minus 3 is equal to negative 10. Three. Subtract the positive integer. We move to the left. For example, 7 minus 3 is equal to 4. 2 minus 4 is equal to 2. Minus 4 is equal to negative 2. 9 plus negative 7 is equal to 9 minus 7, which is equal to 2. 4. Subtract a negative integer. We move to the right. For example, negative 2 minus negative 1 is equal to negative 2 plus 1, which is equal to negative 1. Negative 4 minus negative 6 is equal to negative 4 plus 6, which is equal to 2. 3 minus negative 4 is equal to 3 plus 4, which is equal to 7. State whether the following statements are correct or incorrect. Correct those which are wrong. 1. When two positive integers are added, we get a positive integer. 2. When two negative integers are added, we get a positive integer. 3. When a positive integer and a negative integer are added, we always get a negative integer. 4. Additive inverse of an integer 8 is negative 8, and additive inverse of negative 8 is 8. 5. For subtraction, we add the additive inverse of the integer that is being subtracted to the other integer. 6. Negative 10 plus 3 is equal to 10 minus 3. 7. 8 plus negative 7 minus negative 4 is equal to 8 plus 7 minus 4. The solution. 1. Correct, since 67 plus 53 is equal to 120. 279 plus 510 is equal to 789. 345 plus 134 is equal to 479. 2. Incorrect, since negative 6 plus negative 7 is equal to negative 13, which is not a positive integer. The correct statement is: when two negative integers are added, we get a negative integer. For example, negative 56 plus negative 73 is equal to negative 129. Negative 113 plus negative 82 is equal to negative 195. Negative 57 plus negative 63 is equal to negative 120. 3. Incorrect. Since negative 9 plus 16 is equal to 7, negative 73 plus 81 is equal to 8, which is not a negative integer. The correct statement is, when one positive and one negative integers are added, we take their difference and place the sign of the bigger integer. The bigger integer is decided by ignoring the signs of both the integers. For example, negative 56 plus 73 is equal to 17. Negative 113 plus 82 is equal to negative 31. 125 plus negative 101 is equal to 24. 4. Correct, because additive inverse of 10 is negative 10. Additive inverse of negative 10 is 10. Additive inverse of 76 is negative 76. Additive inverse of negative 76 is 76. Thus, the additive inverse of any integer, a, is negative a, and additive inverse of negative a is a. 5. Correct. Subtraction is opposite of addition, and therefore we add the additive. Inverse of the integer is being subtracted to the other integer. For example, 56 minus 73 is equal to 56 plus additive inverse of 73, which is equal to 56 plus negative 73, which is equal to negative 17. 56 minus negative 73 is equal to 56 plus additive inverse of negative 73, which is equal to 56 plus 73, which is equal to 129. Negative 79 minus 45 is equal to negative 79 plus additive inverse of 45, which equals to negative 79 minus 45, which is equal to minus 124. Thus, we find that for any two integers, a and b, a minus b is equal to a plus additive inverse of b, which is equal to a plus negative b, and a minus negative b equals to a plus additive inverse of negative b, which equals to a plus b. 6. Incorrect. Since negative 10 plus 3 is equal to minus 7 and 10 minus 3 is equal to 7. Therefore, negative 7 is not equal to 7. The correct statement is negative 10 plus 3 is equal to 3 minus 10. 7. Incorrect. Since 8 plus negative 7 minus negative 4 is equal to 8 plus negative 7 plus 4, which is equal to 8, negative 7 plus 4 is equal to 5. And 8 plus 7 minus 4 is equal to 15 minus 4, which is equal to 11. However, 8 plus negative 7 minus negative 4 is not equal to 8 plus 7 minus 4. Therefore, the correct statement is 8 plus negative 7 minus negative 4 is equal to 8 minus 7 plus 4. Example. At Srinagar, the temperature was minus 5 degrees on Monday, and then it dropped by 2 degrees Celsius on Tuesday. What was the temperature of Srinagar on Tuesday? On Wednesday, it rose by 4 degrees Celsius. What was the temperature on this day? Solution. Here the temperature on Monday is equal to 5 degrees Celsius. Therefore, the temperature on Tuesday is equal to temperature on Monday minus 2 degrees Celsius, which is equal to minus 5 degrees Celsius minus 2 degrees Celsius, which is equal to minus 7 degrees Celsius. And temperature on Wednesday is equal to temperature on Tuesday plus 4 degrees Celsius, which is equal to minus 7 degrees Celsius plus 4 degrees Celsius, which is equal to minus 3 degrees Celsius. Therefore, the temperature on Tuesday and Wednesday are minus 7 degrees Celsius and minus 3 degrees Celsius respectively. Example. In a magic square, each row, column, and diagonal have the same sum. Check which of the following is a magic square. The solution. Here, from the figure 1, each row and column have sum 0. Whenever the sum of diagonal is not 0, like negative 4 plus negative 2 plus 0 is equal to minus 6 is not equal to 0. Therefore, figure 1 is not a magic square. Now, from figure 2, each row, column, and diagonal have sum minus 9. Therefore, figure 2 is a magic square. Example. Use the sign more, less, or equals to in the box to make the statement true. A. Negative 8 plus negative 4. Box negative 8 minus negative 4. B. Negative 3 plus 7 minus 19. Box 15 minus 8 plus negative 9. C. 23 minus 41 plus 11. Box 23 minus 41 minus 11. D. 39 plus negative 24 minus 15. Box 26 plus negative 52 minus negative 36. E. Negative 231 plus 79 plus 51. Box negative 399 plus 159 plus 81. Solution. A. Negative 12 is less than negative 4. B. Negative 15 is less than negative 2. C. Negative 7 is more than negative 29. D. 0 is less than 10. E. Negative 101 is more than negative 159. Example. Can you find a pattern for each of them? If yes, fill in the blanks. A. 7, 3, -1, -5, dash, 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 dash. Solution. Here the difference between any two consecutive integers is -4. Like 7 minus 4 is equal to 3, 3 minus 4 is equal to -1. -1 minus 4 is equal to -5. Therefore, -5 minus 4 is equal to -9. -9 minus 4 is equal to -13. -13 minus 4 is equal to -17. And -17 minus 4 is equal to -21. Thus, the missing numbers are -9, -13, -17 and -21. B. -2, -4, -6, -8, dash, 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 dash. Solution. Here, the difference between any two consecutive integers is -2. Like, -2 minus 2 is equal to -4. -4 minus 2 is equal to -6. -6 minus 2 is equal to -8. Therefore, -8 minus 2 is equal to -10. -10 minus 2 is equal to -12. -12 minus 2 is equal to -14. And -14 minus 2 is equal to -16. Thus, the missing numbers are -10, -12, -14 and -16. C. 15, 10, 5, 0, dash, 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 dash. Solution. Here, the difference between any two consecutive integers is -5. Like 15 minus 5 is equal to 10. 10 minus 5 is equal to 5. 5 minus 5 is equal to 0. Therefore, 0 minus 5 is equal to -5. -5 minus 5 is equal to -10. -10 minus 5 is equal to -15. And -15 minus 5 is equal to -20. Thus, the missing numbers are -5, -10, -15 and -20. D. -11, -8, -5, -2, dash, 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 dash. Solution. Here, the difference between any two consecutive integers is 3. Like, -11 plus 3 is equal to -8. -8 plus 3 is equal to -5. -5 plus 3 is equal to -2. Therefore, -2 plus 3 is equal to 1. 1 plus 3 is equal to 4. 4 plus 3 is equal to 7. And 7 plus 3 is equal to 10. Thus, the missing numbers are 1, 4, 7 and 10. Properties of addition and subtraction of integers. Closure under addition. Now, we have learnt that sum of two whole numbers is again a whole number. For example, 17 plus 24 is equal to 41. Here both numbers 17 and 24 are whole numbers, and the sum of 17 and 24 is 41, which is again a whole number. We know that this property is known as the closure property for addition of the whole numbers. Observe whether this property is true for integers or not. Check the given table carefully. Here, for every statement, the result is an integer. Thus, the sum of two integers is always an integer. Since addition of integers gives integers, we say integers are closed under addition. In general, for any two integers, a and b, a plus b is an integer. Closure under subtraction. We know that the difference between two integers is always an integer. For example, 25 minus 32 is equal to -7. Observe the given table to check whether the integers are closed under subtraction or not. For every statement of the given table, result is again an integer. We can see that integers are closed under subtraction. Thus, if a and b are two integers, then a minus b is also an integer. Commutative property. We know that 3 plus 5 is equal to 5 plus 3, which is equal to 8. That is, the whole numbers can be added in any order. In other words, addition is commutative for whole numbers. Like 5 plus -6 is equal to -1, and -6 plus 5 is equal to -1. So, 5 plus -6 is equal to -6 plus 5. Try this with some more examples. In general, for any two integers, a and b, we can say a plus b is equal to b plus a. We know that subtraction is not commutative for whole numbers. Is it commutative for integers? Consider the integers 5 and -3. 1. 5 minus -3 is equal to 5 plus 3, which is equal to 8. And -3 minus 5 is equal to -3 minus 5, which is equal to -8. Therefore, 5 minus -3 is not equal to -3 minus 5. 2. For integers 7 and -9. 7 minus -9 is equal to 7 plus 9, which is equal to 16. And -9 minus 7 is equal to -9 minus 7, which is equal to -16. Therefore, 7 minus -9 is not equal to -9 minus 7. We conclude that subtraction is not commutative for integers. associative property. Observe the following examples. Consider the integers -3, -2 and -5. Look at -5 plus -3 plus -2 and -5 plus -3 plus -2. In the first sum, -3 and -2 are grouped together, and in the second, -5 and -3 are grouped together. We will check whether we get different results. In both the cases, we get -10. That is, -5 plus -3 plus -2 is equal to -5 plus -3 plus -2. Similarly, consider -3, 1 and -7. -3 plus 1 plus -7 and -3 plus 1 plus -7. -3 plus 1 plus -7 is equal to -3 plus -6, which is equal to -9. And -3 plus 1 plus -7 is equal to -2 plus -7, which is equal to -9. Therefore, -3 plus 1 plus -7 is equal to -3 plus 1 plus -7, which is equal to -9. In general, for any integers a, b and c, we can say a plus b plus c is equal to a plus b plus c. Additive identity. When we add 0 to any whole number, we get the same whole number. 0 is an additive identity for whole numbers. Is it an additive identity again for integers also? Let us try to understand this with some examples. The examples we solved here show that 0 is an additive identity for integers. In general, for any integer a plus 0 is equal to a, which is equal to 0 plus a. For example, write down a pair of integers whose a sum is -3, b difference is -5, c difference is 2, d sum is 0. Solutions. A. -7 plus 4 is equal to -3, or -1 plus -2 is equal to -3. B. -8 minus -3 is equal to -5, or -4 minus 1 is equal to -5. C. -6 minus -8 is equal to 2, or 1 minus -1 is equal to 2. D. -16 plus 16 is equal to 0, or -7 minus -7 is equal to 0. Note, you can check these by taking any integers. For example, fill in the blanks to make the following statements true. 1. -5 plus -8 is equal to -8 plus dash. Solution. The answer of the given statement is -5 because of commutative property. 2. Negative 53 plus dash is equal to negative 53. Solution. The answer of given statement is 0 because of additive identity. 3. 17 plus dash is equal to 0. Solution. The answer of given statement is negative 17 because of additive inverse. 4. 13 plus negative 12 plus dash is equal to 13 plus negative 12 plus negative 7. Solution. The answer of given statement is negative 7 because of associative property. 5. Negative 4 plus 15 plus negative 3 is equal to negative 4 plus 15 plus dash. The answer of given statement is negative 3 because of associative property. Multiplication of integers. We can add and subtract integers. Let us now learn how to multiply integers. Multiplication of a positive and a negative integer. We know that multiplication of whole numbers is repeated addition. For example, 5 plus 5 plus 5 is equal to 3 multiplied by 5, which is equal to 15. We have from the following number line, negative 5 plus negative 5 plus negative 5 equals to negative 15. But we can also write negative 5 plus negative 5 plus negative 5 equals to 3 multiplied by negative 5, which equals to negative 15. Therefore, 3 multiplied by negative 5 equals to negative 15. Let us see how to find the product of a positive integer and a negative integer without using the number line. Let us find out 3 multiplied by negative 5 in a different way. First find 3 multiplied by 5 and then put a minus sign before the product obtained. You get negative 15. That is, we find minus 3 multiplied by 5 to get minus 15. Similarly, 5 multiplied by negative 4 is equal to minus 5 multiplied by 4, which is equal to negative 20. Find in a similar way 4 multiplied by negative 8, which is equal to minus 4 multiplied by 8, which is equal to negative 32. 3 multiplied by negative 7, which is equal to minus 3 multiplied by 7, which is equal to negative 21. 6 multiplied by negative 5 equals to minus 6 multiplied by 5, which is equal to negative 30. 10 multiplied by negative 43 equals to minus 10 multiplied by 43, which equals to negative 430. We thus find that while multiplying a positive integer and a negative integer, we multiply them as whole numbers and put a minus sign before the product. We thus get a negative integer. In general, for any two positive integers, a and b, we can say a multiplied by negative b is equal to negative b multiplied by a, which is equal to minus a multiplied by b. For example, find the product. 1. 15 multiplied by negative 16. 2. 21 multiplied by negative 32. 3. Negative 42 multiplied by 12. 4. Negative 55 multiplied by 15. 5. 25 multiplied by negative 21. Solutions. 1 is equal to negative 16 multiplied by 15, which is equal to minus 16 multiplied by 15, which is equal to negative 240. 2 is equal to negative 32 multiplied by 21, which is equal to minus 32 multiplied by 21, which is equal to negative 672. 3 is equal to minus 42 multiplied by 12, which is equal to negative 504. 4 is equal to minus 55 multiplied by 15, which equals to negative 825. 5 is equal to negative 21 multiplied by 25, which equals to minus 21 multiplied by 25, which equals to negative 525. Multiplication of two negative integers. We know that when we multiply the two negative integers as whole numbers and put the positive sign before the product, like 1. Minus 3 multiplied by minus 2 is equal to 6. 2. Negative 3 multiplied by negative 3 is equal to 9. 3. Negative 3 multiplied by negative 4 is equal to 12. In general, for any two positive integers, a and b, negative a multiplied by negative b equals to a multiplied by b. Example. Find 1. Negative 31 multiplied by negative 100. 2. Negative 25 multiplied by negative 72. 3. Negative 83 multiplied by negative 28. Solution. 1. Negative 31 multiplied by negative 100 equals to 3100. 2. Negative 25 multiplied by negative 72 equals to 1800. 3. Negative 83 multiplied by negative 28 equals to 2324. Activity. Take a board marked from minus 104 to 104 as shown here. Take a bag containing 2 blue and 2 red dice. The number of dots on the blue dice indicate positive integers, and the number of dots on the red dice indicate negative integers. Every player will place his or her counter at 0. Now, each player will take out 2 dice at a time from the bag and throw them. After every throw, the player has to multiply the number marked on the dice. If the product is a positive integer, then the player will move his counter toward 104. If the product is a negative integer, then the player will move his counter towards minus 104. The player who reaches minus 104 or 104 first is the winner. Here we have total 3 possibilities of getting 2 blue or 2 red dice. For example, when both the dice are blue, we get 2 positive integers, whose product is also positive. Or, if 2 dice are red, then we get both negative integers, whose product is also positive integer. Now, suppose 1 red and 1 blue dice are thrown, and then we get 1 negative and 1 positive integer, whose product is negative integer. Or when 1 blue and when 1 red dice are thrown, then again the product is negative. Suppose both blue dice have integers 3 and 4, then product of 3 and 4 is 3 multiplied by 4, which is equal to 12. Similarly, if both the red dice have integers 2 and 5, then their product, negative 2 multiplied by negative 5, is equal to 10. If 1 red and 1 blue dice have integers 4 and 3, then negative 4 multiplied by 3 is equal to negative 12. The game moves on like this. The player who reaches either negative 104 or 104 first is the winner. Play this game with your friends. Product of 3 or more negative integers. We observed that the product of 2 negative integers is a positive integer. The product of 3 negative integers is a negative integer. The product of 4 negative integers is a positive integer. Similarly, the product of 5 negative integers is a negative integer. Similarly, like this, we can get product of 6 negative integers, and so on. We find that if the number of negative integers in a product is even, then the product is a positive integer. If the number of negative in a product is odd, then the product is a negative integer. Here, negative 9 multiplied by negative 5 multiplied by negative 6 multiplied by negative 3 is equal to 810, which is a positive integer, because the number of negative integers is even. Whenever negative 9 multiplied by negative 5 multiplied by 6 multiplied by negative 3 is equal to negative 810, which is a negative integer, because the number of negative integers is odd. Example: what will be the sign of the product if we multiply together? 1. 8 negative integers and 3 positive integers. 2. 5 negative integers and 4 positive integers. 3. Negative 1, 12 times. 4. Negative 1, 2m times. M is a natural number. Solution: here the number of negative integers is 8, which is an even number, so their product is positive. Thus, the product of 8 negative integers and 3 positive integers, that is, the product of positive integer with positive integer is positive. 2. Here, the number of negative integers is 5, which is an odd number. So, their product is negative. While the product of 4 positive integers is positive. Therefore, the product of 5 negative and 4 positive integers, that is, product of negative integer with positive integer, is negative integer. 3. Here, negative 1 is multiplied by 12 times, and 12 is an even number. So the answer is a positive integer. 4. Here, m is a natural number, and m equals to 1, 2, 3, 4, and so on. So, 2m is an even natural number. Thus, negative 1 is multiplied 2m times, so the answer is a positive integer. Properties of multiplication of integers. Closure under multiplication. We know that the product of two integers is again an integer, which is given in the table. Thus, the answer of every statement of a given table is an integer. In general, a multiplied by b is an integer for all integers a and b. Commutativity of multiplication. We know that multiplication is commutative for the whole numbers. Can we say multiplication is also commutative for integers? In the given table, the answers of both the statements 1 and statement 2 are the same. So, multiplication is commutative for integers. In general, for any two integers a and b, a multiplied by b is equal to b multiplied by a. Multiplication by 0. We know that any whole number when multiplied by 0 gives 0. Similarly, any integer when multiplied by 0 gives 0. For example, negative 3 multiplied by 0 is equal to 0. 0 multiplied by negative 4 is equal to 0. 7 multiplied by 0 is equal to 0. 0 multiplied by 8 is equal to 0. This shows that the product of a negative integer and 0 is 0. In general, for any integer a multiplied by 0 is equal to 0 multiplied by a, which is equal to 0. Multiplicative identity. We know that 1 is the multiplicative identity for whole numbers. Check that 1 is the multiplicative identity for integers as well. Observe the following products of integers with 1. Negative 3 multiplied by 1 is equal to negative 3. Negative 4 multiplied by 1 is equal to negative 4. 1 multiplied by negative 5 is equal to negative 5. 1 multiplied by negative 6 is equal to negative 6. 1 multiplied by 5 is equal to 5. 1 multiplied by 8 is equal to 8. 3 multiplied by 1 is equal to 3. 7 multiplied by 1 is equal to 7. This shows that 1 is the multiplicative identity for integers also. In general, for any integer a, we have a multiplied by 1 is equal to 1 multiplied by a, which is equal to a. Associativity for multiplication. Consider negative 3, negative 2 and 5. Now look at negative 3 multiplied by negative 2 into 5 and negative 3 multiplied by negative 2 multiplied by 5. In the first case, negative 3 and negative 2 are grouped together, and in the second, negative 2 and 5 are grouped together. In the first case, negative 3 multiplied by negative 2 is equal to 6, and 6 multiplied by 5 is equal to 30. Similarly, in the second case, negative 2 multiplied by 5 is equal to negative 10, and multiplying it by negative 3, we get 30. So, we get the same answer in both the cases. Thus, like whole numbers, the product of these three integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers. Now, fill in the blanks by using this rule. The answer of the first blank is negative 42, and multiplying it by 4, we get negative 168. Similarly, the answer of the second blank is negative 24, and multiplying it by 7, we get negative 168. In general, for any three integers, a, b, and c, a multiplied by b multiplied by c is equal to a multiplied by b multiplied by c. Distributive property. Let us understand distributivity of multiplication over addition. 1. 16 multiplied by 10 plus 2 is equal to 16 multiplied by 10 plus 16 multiplied by 2. That is, 16 multiplied by 10 plus 2 is equal to 16 multiplied by 12, which is equal to 192. And 16 multiplied by 10 plus 16 multiplied by 2 is equal to 160 plus 32, which is equal to 192. Thus, 16 multiplied by 10 plus 2 is equal to 16 multiplied by 10 plus 16 multiplied by 2. 2. Negative 4 multiplied by negative 2 plus 7 is equal to negative 4 multiplied by negative 2 plus negative 4 multiplied by 7. That is, negative 4 multiplied by negative 2 plus 7 is equal to negative 4 multiplied by 5, which is equal to negative 20. And negative 4 multiplied by negative 2 plus negative 4 multiplied by 7 is equal to 8 plus negative 28, which is equal to negative 20. Thus, negative 4 multiplied by negative 2 plus 7 is equal to negative 4 multiplied by negative 2 plus negative 4 multiplied by 7. 3. Negative 8 multiplied by negative 2 plus negative 1 is equal to negative 8 multiplied by negative 2 plus negative 8 multiplied by negative 1. That is, negative 8 multiplied by negative 2 plus negative 1 is equal to negative 8 multiplied by negative 3 is equal to 24. And negative 8 multiplied by negative 2 plus negative 8 multiplied by negative 1 is equal to 16 plus 8, which is equal to 24. Thus, negative 8 multiplied by negative 2 plus negative 1 is equal to negative 8 multiplied by negative 2 plus negative 8 multiplied by negative 1. Thus, we can say the distributivity of multiplication over addition is true for integers. In general, for any integers a, b, and c, a multiplied by b plus c is equal to a multiplied by b plus a multiplied by c. For example, is 10 multiplied by 6 plus negative 2 is equal to 10 multiplied by 6 plus 10 multiplied by negative 2? Solution. 10 multiplied by 6 plus negative 2 is equal to 10 multiplied by 4, which is equal to 40. And 10 multiplied by 6 plus 10 multiplied by negative 2 is equal to 60 plus negative 20, which is equal to 40. Thus, 10 multiplied by 6 plus negative 2 is equal to 10 multiplied by 6 plus 10 multiplied by negative 2. For example, can we say 4 into brackets 3 minus 8 close bracket is equal to 4 multiplied by 3 minus 4 multiplied by 8? Solution. 4 multiplied by 3 minus 8 is equal to 4 multiplied by negative 5, which is equal to negative 20. And 4 multiplied by 3 minus 4 multiplied by 8 is equal to 12 minus 32, which is equal to negative 20. So, 4 multiplied by 3 minus 8 is equal to 4 multiplied by 3 minus 4 multiplied by 8. For example, is 10 multiplied by 6 minus negative 2 is equal to 10 multiplied by 6 minus 10 multiplied by negative 2? Solution. 10 multiplied by 6 minus negative 2 is equal to 10 multiplied by 8, which is equal to 80. And 10 multiplied by 6 minus 10 multiplied by negative 2 is equal to 60 minus negative 20, which is equal to 80. Thus, 10 into 6 minus negative 2 is equal to 10 multiplied by 6 minus 10 multiplied by negative 2. Example. Is negative 15 into negative 7 minus negative 1 equals to negative 15 into negative 7 minus negative 15 into negative 1? Solution. Negative 15 multiplied by negative 7 minus negative 1 is equal to negative 15 multiplied by negative 6, which is equal to 90. And negative 15 multiplied by negative 7 minus negative 15 multiplied by negative 1 is equal to 105 minus 15, which is equal to 90. Thus, negative 15 multiplied by negative 7 minus negative 1 is equal to negative 15 multiplied by negative 7 minus negative 15 multiplied by negative 1. In general, for any three integers a, b, and c, a multiplied by b minus c is equal to a multiplied by b minus a multiplied by c. Making multiplication easier. Consider negative 25 multiplied by 37 multiplied by 4 is equal to negative 25 multiplied by 37 multiplied by 4 is equal to negative 925 multiplied by 4, which is equal to negative 3700. 1. Or we can do it this way. Negative 25 multiplied by 37 multiplied by 4 is equal to negative 25 multiplied by 4 multiplied by 37, which is equal to negative 100 multiplied by 37, which is equal to negative 3700. Which is the easier way? Obviously, the second way is easier because multiplication of negative 25 and 4 gives negative 100, which is easier to multiply with 37. Note that the second way involves commutativity and associativity of integers. So, we find that the commutativity, associativity, and distributivity of integers help to make our calculations simpler. Now let us further see how calculations can be made easier using these properties. Example. Find 1. 16 multiplied by 12. 2. Negative 23 multiplied by 48. 3. Negative 35 multiplied by negative 98. 4. 52 multiplied by negative 8 plus negative 52 multiplied by 2. The solution. 1. 16 multiplied by 12 can be written as 16, 10 plus 2, which is equal to 16 multiplied by 10 plus 16 multiplied by 2, which is equal to 160 plus 32, which is equal to 192. 2. Negative 23 multiplied by 48 is equal to negative 23 multiplied by 50 minus 2, which is equal to negative 23 multiplied by 50 minus negative 23 multiplied by 2, which is equal to negative 1150 minus negative 46, which is equal to negative 1150 plus 46, which is equal to negative 1104. 3. Negative 35 multiplied by negative 98 is equal to negative 35 multiplied by negative 100 plus 2, which is equal to negative 35 multiplied by negative 100 plus negative 35 multiplied by 2, which is equal to 3500 minus 70, which is equal to 3430. 4. 52 multiplied by negative 8 plus negative 52 multiplied by 2 is equal to 52 multiplied by negative 8 plus negative 52 multiplied by 2 can also be written as 52 multiplied by negative 2, which is equal to 52 multiplied by negative 8 plus negative 2, which is equal to 52 multiplied by negative 10, which is equal to negative 520. 5. Negative 49 multiplied by 18. 6. Negative 25 multiplied by negative 31. 7. 70 multiplied by negative 19. 8. 70 multiplied by negative 19 plus negative 1 multiplied by 70. Solution. 5. Negative 49 multiplied by 18 is equal to negative 50 plus 1 multiplied by 18, which is equal to negative 50 multiplied by 18 plus 1 multiplied by 18, which is equal to negative 900 plus 18, which is equal to negative 882. 6. Negative 25 multiplied by negative 31 is equal to negative 25 multiplied by negative 30 minus 1, which is equal to negative 25 multiplied by negative 30 minus negative 25 multiplied by 1, which is equal to 750 plus 25, which is equal to 775. 7. 70 multiplied by negative 19 is equal to 70 multiplied by negative 20 plus 1 is equal to 70 multiplied by negative 20 plus 70 multiplied by 1, which is equal to negative 1400 plus 70, which is equal to negative 1330. 8. 70 multiplied by negative 19 plus negative 1 multiplied by 70 is equal to 70 multiplied by negative 19 plus 70 multiplied by negative 1 equals to 70 multiplied by negative 19 plus negative 1, which equals to 70 multiplied by negative 19 minus 1, which is equal to 70 multiplied by negative 20, which is equal to negative 1400. 9. Negative 18 multiplied by negative 10 multiplied by 9. 10. Negative 20 multiplied by negative 2 multiplied by negative 5 multiplied by 7. 11. Negative 1 multiplied by negative 5 multiplied by negative 4 multiplied by negative 6. 12. Negative 30 multiplied by 13 plus negative 3 equals to negative 30 multiplied by 13 plus negative 30 multiplied by negative 3. Solution. 9. Negative 18 multiplied by negative 10 multiplied by 9 is equal to negative 18 multiplied by negative 10 multiplied by 9 is equal to 180 multiplied by 9, which equals to 1620. 10. Negative 20 multiplied by negative 2 multiplied by negative 5 multiplied by 7 is equal to negative 20 multiplied by negative 2 multiplied by negative 5 multiplied by 7 is equal to negative 20 multiplied by 10 multiplied by 7, which equals to negative 200 multiplied by 7 which equals to negative 1400. 11. Negative 1 multiplied by negative 5 multiplied by negative 4 multiplied by negative 6 is equal to negative 1 multiplied by negative 6 multiplied by negative 4 multiplied by negative 5 equals to 6 multiplied by 20, which equals to 120. 12. Negative 30 multiplied by 13 plus negative 3 equals to negative 30 multiplied by 13 plus negative 30 multiplied by negative 3. Negative 30 multiplied by 13 plus negative 3 is equal to negative 30 multiplied by 10, which equals to negative 300. And negative 30 multiplied by 13 plus negative 30 multiplied by negative 3 equals to negative 390 plus 90, which equals to negative 300. Therefore, negative 30 multiplied by 13 plus negative 3 is equal to negative 30 multiplied by 13 plus negative 30 multiplied by negative 3. Example. In a class test containing 15 questions, 4 marks are given for every correct answer, and negative 2 marks are given for every incorrect answer. Gurpreet attempts all the questions, but only 9 of her answers are correct. What is her total score? 2. One of her friends gets only 5 answers correct. What will be her score? Solution. 1. The marks given for one correct answer equals to 4. So the marks given for 9 correct answers equals to 4 multiplied by 9, which equals to 36. Marks given for one correct answer is equal to minus 2. So marks given for 6 equals to 15 minus 9. Incorrect answers equals to negative 2 multiplied by 6, which equals to negative 12. Therefore, Gurpreet's total score equals to 36 plus negative 12, which equals to 24. 2. Marks given for one correct answer equals to 4. So the marks given for 5 correct answers equals to 4 multiplied by 5, which equals to 20. Marks given for one incorrect answer equals to minus 2. So the marks given for 15 minus 5 is equal to 10. Incorrect answers equals to 10 multiplied by minus 2, which equals to minus 20. Therefore, her friend's total score is equal to 20 plus negative 20, which equals to 0. Example. Suppose we represent the distance above the ground by a positive integer and that below the ground by a negative integer. Then answer the following. 1. An elevator descends into a mine shaft at the rate of 5 meters per minute. What will be its position after 1 hour? 2. If it begins to descend from 15 meters above the ground, what will be its position after 45 minutes? Solution. 1. Since the elevator is going down, so the distance covered by it will be represented by a negative integer. Change in position of the elevator in 1 minute equals to minus 5 meters. Position of the elevator after 60 minutes equals to negative 5 multiplied by 60, which equals to negative 300 meters. That is 300 meters below down from the starting position of the elevator. 2. The change in the position of the elevator in 45 minutes equals to negative 5 multiplied by 45, which equals to negative 225 meters. That is 225 meters below ground level. So, the final position of the elevator equals to minus 225 plus 15, which equals to minus 210 meters. That is 210 meters below the ground level. Example. For any integer a, what is negative 1 multiplied by a? Solution. Here the multiplication of any integer a with minus 1, the answer is its additive inverse, that is, a with opposite sign. For example, if the value of a is 7, then the answer is negative 7. And if a equals to negative 16, the answer is 16. Example. A cement company earns a profit of 8 rupees per bag of white cement sold and a loss of 5 rupees per bag of grey cement sold. 1. The company sells 3,000 bags of white cement and 5,000 bags of grey cement in a month. What is its profit or loss? 2. What is the number of white cement bags it must sell to have neither profit nor loss if the number of grey bags sold is 6,400 bags? Solution. 1. A cement company earns a profit of 8 rupees per bag of white cement sold. The company sells 3,000 bags of white cement. So the profit gain is 3,000 multiplied by 8, which equals to 24,000. Now, a loss of 5 rupees per bag of grey cement sold. Therefore, the loss is 5,000 multiplied by minus 5, which equals to negative 25,000. So the total loss is 25,000 rupees. Here, the loss on the grey cement is more than the profit gain on the white cement. Therefore, the company has suffered a loss. Thus, 24,000 plus negative 25,000 equals to negative 1,000. That is, the company bears a loss of 1,000 rupees. 2. We know that the cement company has a loss of 5 rupees per bag of grey cement sold. Therefore, if 6,400 bags are sold, then the loss will be 6,400 multiplied by minus 5, which equals to minus 32,000 rupees. That is, loss is equal to 32,000 rupees. Now, the company has to sell white cement bags to gain profit of 32,000 rupees to have neither profit nor loss. Thus, to earn profit of 32,000 rupees, the company has to sell 4,000 white cement bags because 4,000 multiplied by 8 is equal to 32,000 rupees. Thus, minus 32,000 plus 32,000 is equal to 0 rupees. Thus, 4,000 white cement bags it must sell to have neither profit nor loss. division of integers. We know that division is the inverse operation of multiplication. Let us see an example for whole numbers. Since 3 multiplied by 5 is equal to 15, so 15 divided by 5 is equal to 3, and 15 divided by 3 is equal to 5. Similarly, 4 multiplied by 3 is equal to 12 gives 12 divided by 3 equals to 4, and 12 divided by 4 which equals to 3. We can say for each multiplication statement of whole numbers, there are 2 division statements. Observe the examples in the given table. In general, for any 2 positive integers, a and b, a divided by minus b is equal to minus a divided by b, when b is not equal to 0. 1. 125 divided by minus 25 is equal to minus 5. 2. 80 divided by minus 5 is equal to minus 16. 3. 64 divided by minus 16 is equal to minus 4. We observe that when we divide a positive integer by a negative integer, we first divide them as whole numbers and then put a minus sign before the quotient. Therefore, we get a negative integer. So, in general, for any 2 positive integers, a and b, minus a divided by minus b is equal to a divided by b when b is not equal to 0. For example, 1. Minus 12 divided by minus 6 is equal to 2. 2. Minus 20 divided by minus 5 is equal to 4. 3. Minus 32 divided by minus 8 is equal to 4. 4. Minus 45 divided by minus 9 is equal to 5. 5. Minus 36 divided by minus 4 is equal to 9. 6. Minus 201 divided by minus 3 is equal to 67. 7. Minus 325 divided by minus 13 is equal to 25. From this table, we can say that when we divide a negative integer by a negative integer, we first divide them as whole numbers and then put a minus sign before the quotient. Properties of division of integers. We know that integers are not closed under division. Also, we know that division is not commutative for integers. Minus 8 divided by minus 4 is not equal to minus 4 divided by minus 8. Minus 9 divided by 3 is not equal to 3 divided by minus 9. Minus 30 divided by minus 6 is not equal to minus 6 divided by minus 30. Like whole numbers, any integer divided by 0 is meaningless, and 0 divided by an integer other than 0 is equal to 0. That is, for any integer a divided by 0 is not defined But 0 divided by a is equal to 0, for a equals to 0. Any integer divided by 1 gives the same integer. Like, for example, minus 8 divided by 1 is equal to minus 8. Minus 11 divided by 1 is equal to minus 11. Minus 13 divided by 1 is equal to minus 13. Minus 25 divided by 1 is equal to minus 25. Minus 37 divided by 1 is equal to minus 37. Minus 48 divided by 1 is equal to minus 48. So in general, for any integer a divided by 1 is equal to a. We can say that if any integer is divided by minus 1, it does not give the same integer. For example, minus a divided by minus 1 is equal to 8. 11 divided by minus 1 is equal to minus 11. Minus 17 divided by minus 1 is equal to 17. 13 divided by minus 1 is equal to minus 13. Thus, if any integer is divided by minus 1, then the answer is the same integer with the opposite sign. Like when we divide minus 8 by minus 1, we get 8. And if 11 is divided by minus 1, we get minus 11. Example. In a test, plus 5 marks are given for every correct answer, and minus 2 marks are given for every incorrect answer. 1. Radhika answered all the questions and scored 30 marks, though she got 10 correct answers. 2. Jay also answered all the questions and scored minus 12 marks, though he got 4 correct answers. How many incorrect answers had they attempted? The solution. 1. Marks given for 1 correct answer is equal to 5. So marks given for 10 correct answers equals to 5 multiplied by 10 is equal to 50. Radhika's score equals to 30. Marks obtained for incorrect answers equals to 30 minus 50, which equals to minus 20. Marks given for 1 incorrect answer equals to minus 2. Therefore, the number of incorrect answers equals to minus 20 divided by minus 2 equals to 10. Thus, Radhika gave 10 incorrect answers. 2. The marks given for 4 correct answers equals to 5 multiplied by 4, which equals to 20. Jay's score equals to minus 12. Marks obtained for incorrect answers equals to minus 12 minus 20, which equals to minus 32. Marks given for 1 incorrect answer equals to minus 2. Therefore, the number of incorrect answers equals to minus 32 divided by minus 2 equals to 16. Thus, Jay gave 16 incorrect answers. Example. A shopkeeper earns a profit of 1 rupee by selling 1 pen and incurs a loss of 40 paisa per pencil while selling pencils of her old stock. 1. In a particular month, she incurs a loss of 5 rupees. In this period, she sold 45 pens. How many pencils did she sell in this period? 2. In the next month, she earns neither profit nor loss. If she sold 70 pens, how many pencils did she sell? Solution. 1. Profit earned by selling 1 pen equals to 1 rupee. Profit earned by selling 45 pens equals to 45 rupees, which we denoted by plus 45 rupees. The total loss given equals to 5 rupees, which we denoted by minus 5 rupees. The profit earned plus the loss incurred is equal to the total loss. Therefore, the loss incurred equals to the total loss minus the profit earned, which equals to minus 5 minus 45 rupees, which equals to minus 50 rupees, which equals to minus 5,000 paise. The loss incurred by selling 1 pencil equals to 40 paise, which we write as minus 40 paise. So the number of pencils sold equals to minus 5,000 divided by minus 40, which equals to 125. Thus, the shopkeeper sold 125 pencils. 2. In the next month, there is neither profit nor loss. So, the profit earned plus the loss incurred is equal to 0. That is, the profit earned equals to minus loss incurred. Now, profit earned by selling 70 pens is equal to 70 rupees. Hence, the loss incurred by selling pencils equals to 70 rupees, which we indicated by minus 70 rupees or minus 7,000 paisa. So the total number of pencils sold equals to minus 7,000 divided by minus 40, which equals to 175 pencils. Thus, the shopkeeper sold 175 pencils. Example. Verify that A divided by B plus C is not equal to A divided by B plus A divided by C for each of the following values A, B and C. A equals to 12, B equals to minus 4, C equals to 2 and B. A equals to minus 10, B equals to 1, C equals to 1. The solution. A equals to 12, B equals to minus 4 and C equals to 2. Thus, A divided by B plus C equals to 12 divided by minus 4 plus 2, which equals to 12, divided by minus 2, which equals to minus 6. Now, A divided by B plus A divided by C equals to 12 divided by minus 4 plus 12 divided by 2, which equals to minus 3 plus 6, which equals to 3. Therefore, A divided by B plus C is not equal to A divided by B plus A divided by C. B. A equals to minus 10, B equals to 1, and C equals to 1. Thus, A divided by B plus C is equal to minus 10 divided by 1 plus 1, which equals to minus 10 divided by 2, which equals to minus 5. And A divided by B plus A divided by C is equal to minus 10 divided by 1 plus minus 10 divided by 1, which equals to minus 10 plus minus 10, which equals to minus 20. Therefore, A divided by B plus C is not equal to A divided by B plus A divided by C. What have we discussed? 1. Integers are a bigger collection of numbers which is formed by whole numbers and their negatives. These were introduced in class 6. 2. You have studied in the earlier class about the representation of integers on the number line and their addition and subtraction. 3. We now study the properties satisfied by addition and subtraction. A. Integers are closed for addition and subtraction both. That is, A plus B and A minus B are again integers, where A and B are any integers. B. Addition is commutative for integers. That is, A plus B is equal to B plus A for all integers A and B. C. Addition is associative for integers. That is, A plus B plus C is equal to A plus B plus C for all integers A, B, and C. D. Integer 0 is the identity under addition. That is, A plus 0 is equal to 0 plus A is equal to A for every integer A. 4. We studied how integers could be multiplied and found that the product of a positive and a negative integer is a negative integer, whereas the product of two negative integers is a positive integer. For example, minus 2 multiplied by 7 is equal to minus 14, and minus 3 multiplied by minus 8 is equal to 24. 5. The product of even number of negative integers is positive, whereas the product of odd number of integers which are negative is negative. 6. Integers show some properties under multiplication. A. Integers are closed under multiplication. That is, A into B is an integer for any two integers A and B. B. Multiplication is commutative for integers. That is, A multiplied by B is equal to B multiplied by A for any integers A and B. C. The integer 1 is the identity under multiplication. That is, 1 multiplied by A is equal to A multiplied by 1, which equals to A for any integer A. D. Multiplication is associative for integers. That is, A multiplied by B multiplied by C equals to A multiplied by B multiplied by C for any three integers A, B, and C. 7. Under addition and multiplication, integers show a property called distributive property. That is, A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C for any three integers A, B, and C. 8. The properties of commutativity, associativity under addition and multiplication, and the distributive property help us to make our calculations easier. 9. We have also learnt how to divide integers. We found that A. When a positive integer is divided by a negative integer, the quotient obtained is negative and vice versa. B. Division of a negative integer by another negative integer gives positive as a quotient. 10. For any integer a, we have a. A divided by 0 is not defined, and b. A divided by 1 equals to a.